Friends, I discussed combination reaction, decomposition reaction, displacement reaction and double displacement reaction in the previous videos. In this video, I am going to discuss redox reaction with examples. Questions for self-assessment are also included. Consider the chemical reaction when copper is heated in the presence of oxygen to produce copper 2 oxide, also known as cupric oxide. This is the copper powder and this black powder is copper 2 oxide powder. The chemical equation is Cu plus O2 upon heating gives rise to CuO. Consider the chemical reaction when a stream of hydrogen gas is passed over copper 2 oxide under heating condition. The chemical equation is CuO plus H2 upon heating gives rise to Cu plus H2O. In the above equation, H2 gains oxygen and becomes H2O. Gaining oxygen is called oxidation. CuO loses oxygen and becomes Cu. Losing oxygen is called reduction. That means H2 is oxidized to H2O and CuO is reduced to Cu. Consider a reaction between manganese dioxide and hydrochloric acid. The equation is MnO2 plus 4HCl gives rise to MnCl2 aqueous plus 2H2O plus Cl2. In the above reaction, HCl is converted to Cl2 gas. That means it loses hydrogen. Losing hydrogen is also called oxygen. MnO2 is converted to MnCl2. That means it loses oxygen. Losing oxygen is called reduction. From equations 3 and 4, we can infer the following. If a substance gains oxygen or loses hydrogen during a reaction, it is said to be oxidized, and the process is called oxidation. If a substance loses oxygen or gains hydrogen, it is said to be reduced. The process is called reduction. The chemical reactions given in equations 3 and 4 are called redox reactions or oxidation reduction reactions. Definition. Redox reaction is a chemical reaction in which one reactant is oxidized. That means it gains oxygen or loses hydrogen. And the other reactant is reduced. That means it loses oxygen or gains hydrogen. Consider another reaction between zinc oxide and carbon on heating. The equation is ZnO plus C upon heating gives rise to Zn plus CO. In the above equation, ZnO is reduced to Zn metal. C is oxidized to CO. Therefore, it is a redox reaction. Here, C is called the reducing agent, which causes reduction of ZnO. ZnO is called the oxidizing agent, which oxidizes C. Consider the reaction when ferric oxide Fe2O3 is heated in the presence of carbon monoxide. The equation is Fe2O3 plus 3CO upon heating gives rise to 2Fe plus 3CO2. Equation 6 is a redox reaction in which CO is the reducing agent. It reduces Fe2O3 to Fe. Fe2O3 is the oxidizing agent. It oxidizes CO2, CO2. Another definition of oxidation and reduction. Oxidation. If a reactant loses electrons in a chemical reaction, that reactant is said to be oxidized, and the process is called oxidation. If a reactant gains electrons in a chemical reaction, that reactant is said to be reduced, and the process is called reduction. Now, redox reaction. Redox reaction is a chemical reaction in which one of the reactant loses electrons, that is oxidation, and the other reactant gains electrons, that is reduction. Yet another way to define the increase in oxidation state of an atom through a chemical reaction is known as oxidation. The decrease in oxidation state of an atom through a chemical reaction is known as reduction. Now, we must have clarity. What is oxidation state or oxidation number? It is the hypothetical charge of an atom if all its bonds to other atoms were fully ionic. It describes the degree of oxidation, that is loss of electrons, or reduction, that is gain of electrons of an atom in a chemical compound. The oxidation state may be positive, negative, or zero. In case of atoms or molecules of elements and molecules of compounds, the oxidation state is zero, as these are all neutral. But every atom in a compound can be understood in terms of its oxidation state or oxidation number. The oxidation state of an atom in a compound also depends upon the other atom of that compound. For example, consider CO2. In this case, as each oxygen atom can be assigned a negative charge of 2, that is minus 2, two oxygen atoms have a negative charge of 4, that is minus 4. But the CO2 molecule as a whole must be neutral. Therefore, the carbon atom in CO2 has a positive charge of 4. That means its oxidation number is plus 4. Consider the case of CH4, methane. In this case, each hydrogen atom has a charge of plus 1. The charge on 4 hydrogen atoms put together is plus 4. Therefore, the carbon atom has an oxidation number of minus 4, so that the molecule as a whole is neutral. Look here, in CO2, the oxidation number of carbon is plus 4, whereas in CH4, the oxidation number of carbon is minus 4. This simple example shows that the oxidation number of an atom also depends upon the other atom of a compound. With the definitions of oxidation and reduction given above, let us examine the displacement reaction. Consider the chemical reaction between iron and copper sulfate. The chemical equation is Fe plus CuSO4 gives rise to FeSO4 plus Cu. We can understand the equation 7 as per the above definitions of oxidation and reduction. Fe gives rise to Fe2 plus 2 electrons. This is oxidation reaction, increase in oxidation state. Whereas Cu2 plus consumes the 2 electrons and becomes Cu, that is reduction reaction, decrease in oxidation state. You add 7A and 7B, we get Fe plus Cu2 plus gives rise to Fe2 plus Cu. This is a redox reaction. Thus, the displacement reaction mentioned in equation 7 is a redox reaction. You can observe and examine any displacement reaction. You will conclude that all the displacement reactions are redox reactions. Now consider a combination reaction. 2Mg plus O2 gives rise to 2MgO plus heat. In the above equation, oxidation state of Mg is increased from 0 in Mg to plus 2 in MgO. That means Mg is oxidized in the reaction, whereas the oxidation state of O2 is decreased from 0 to minus 2. That means O2 is reduced. Therefore, the combination reaction given above in equation 8 is also a redox reaction. The combination reactions involving two elements to form a new compound are redox reactions. But there are some other combination reactions which are not redox reactions. Let us consider the example CaO plus H2O gives rise to CaOH twice plus heat. The above reaction is a combination reaction but not a redox reaction because there is no change in the oxidation states of Ca or O or H during the above chemical reaction. Therefore, all the chemical combination reactions need not be redox reactions. Only some of them are redox reactions. Now, let us examine whether the decomposition reactions are redox reactions. Take the example 2KClO3 upon heating in the presence of a catalyst manganese dioxide gives rise to 2KCl plus 3O2. Let us examine the oxidation states of K, Cl, O on LHS and RHS. K, the oxidation state is same on both LHS and RHS. But look here, Cl, the oxidation state is reduced from +5 to -1. Whereas for oxygen, the oxidation state is increased from -2 to 0. Right? This is oxidation state of O being increased from -2 to 0 is oxidation. Oxidation state of Cl decreasing from +5 to -1 is reduction. The decomposition reaction given in equation 10 is also a reduction reaction. You can be surprised why Cl oxidation state in KClO3 is +5. This can be explained as follows. In KClO3, as there are 3 oxygen atoms, oxygen O has a charge of -6. Each atom contributes to -2. K has +1 charge. So Cl has the oxidation state of +5 in KClO3 to make the molecule neutral, whereas it has the oxidation state of -1 in KCl. Once again, I must mention that equation 10 is a decomposition reaction and also a redox reaction. But all the decomposition reactions need not be redox reactions. Consider the reaction CaCO3 upon heating gives rise to CaO plus CO2. You consider the oxidation states of Ca, C and O, LHS and RHS. They are same. They are not changed during this decomposition reaction. Therefore, the decomposition reaction given in equation 11 is not a redox reaction. What does it mean now? Some of the decomposition reactions may be redox reactions, but all the decomposition reactions need not be redox reactions. Let us examine whether the double displacement reactions are redox reactions. Consider the following reaction. NaCl plus AgNO3 gives rise to AgCl plus NaNO3. So now you look at the oxidation states of Na, Cl, Ag, N and O, LHS and RHS. They are same. There is no change at all. Therefore, this reaction is not a redox reaction. You can examine any double displacement reaction. You will conclude that it is not a redox reaction. Therefore, all the double displacement reactions are not redox reactions. Self-assessment quiz. Choose the correct option among the given options and justify why that option is correct with proper explanation. Question 1. Which ones of the following are redox reactions? CuO plus H2 upon heating gives rise to Cu plus H2O. 2. CaCO3 upon heating CaO plus CO2. 3. CaO plus H2O CaOH twice plus heat. 4. C plus O2 gives rise to CO2. Options. Option A, 1 and 3 are redox reactions. Option B, 1 and 2. Option C, 2 and 4. Option D, 1 and 4. Choose the correct option. Question 2. Which one of the following statements are correct? Statement 1. All the displacement reactions are redox reactions. Statement 2. All the double displacement reactions are redox reactions. Statement 3. Some of the decomposition reactions are redox reactions. Statement 4. Some of the combination reactions are redox reactions. Now options. Option A, 1, 2 and 4 correct. Option B, 2, 3 and 4 correct. Option C, 1, 3 and 4 correct. Option D, 1, 2 and 3 correct. Now, question 3, assertion and reason type. Assertion. Zn plus FeSO4 aqueous gives rise to ZnSO4 aqueous plus Fe. This reaction is a redox reaction. Reason. The oxidation state of Zn is increased from 0 to 2 in this reaction, and the oxidation state of Fe is decreased from 2 to 0. Options. Option A is correct and R is wrong. Option B, A is wrong and R is correct. Option C, both A and R are wrong. Option D, both A and R are correct. Other questions. Define a redox reaction in 2 different ways. Give 2 examples for both the definitions with the balanced equations. Question 2. Consider the reaction MnO2 solid plus 4HCl gives rise to MnCl2 plus 2H2O plus Cl2. Is this a redox reaction? Justify your answer with detailed explanation. Question 3. Define oxidation state or oxidation number. Explain with an example how it is useful in deciding whether a reaction is a redox reaction or not. Question 4. Consider the reaction 2KClO3 solid upon heating in the presence of MnO2 catalyst 2KCl plus 3O2. Analyze whether this reaction is a redox reaction and explain in detail. Conclusion. The concept of redox reaction has to be understood with greater clarity. Answer all the questions independently in your notebook. When you answer the multiple choice questions, justify the correct option with reasoning. That is the way you have to learn the concepts. Apply your conceptual knowledge to analyze many other chemical reactions to decide whether they are redox reactions or not. I wish you the best in your efforts.